Any questions on 1, 2, or 3? How to type them in your calculator or anything? And name that another. Ryan, you're sitting in Ryan's chair over there. You're sitting, are you still working on those? So yes. Alright, so moving on now. I told y'all on Friday, should be simmer down. On Friday, I told y'all I would have not, and I did not when I worked this, I did not follow the directions on 4 through 8 to get to log base on my calculator. I just hit math, scroll it down and pick the one that says log base, and then I just filled those in and typed them just like they said. Okay, so if you need to practice doing that, do that now. I rounded mine. I might have rounded mine a little bit different because the directions didn't say. My general rule is I always round how I think they expect me to, and they had 1, 2, 3, 4, so that's tenths, hundredths. They had 10 thousandths, so I rounded to the 10 thousandths when I worked it, but then I told Kylie she could round to the hundredths, so I wouldn't be marking you wrong on your rounding. But so for number 4, I had 2.8907. So if you had 2.89, that would be the same thing. If you need help getting these on your calculator, now's the time to tell me. Okay, everybody all right on that? Number 5, I had 0.5688. So y'all might have had 0.57 if you rounded to hundredths. Everybody okay on that?
Wait, what did you say?
0.5688. What'd you get?
0.57.
That'd be good. Yes, ma'am. Okay, on 6, where's that one? I had 3.4594, which if you rounded to hundredths would be 0.46, 3.46. Okay, then on 7 and 8 there were multiple parts, but I could still do that in the calculator, and you could too. So since it's like got a minus, you might have to practice typing that in there. But I got for number 7, I got 2.7297. Did y'all get that? 2.73? Good, good, good. So y'all were good at typing that in. Then on number 8, they got a 3-parter. I got 1.610. 1.16. I left a 1 off there. 1.16. Is that what y'all had? Alright. So 1 through 8, they're pretty easy. Don't miss points on that. Everybody ought to be able to get all those right. Now, I told y'all that we're confused on 9 through 12. These are the ones that are the most difficult to me. And so I get it that y'all struggle with those a little bit. On 9, what I would do is I would go to my y equals, and I would type in log of x. I would graph, that's your parent function they give you. I would graph that, and then they show me the graph of 1 here. Let's see if I can, it goes to 1. Show me the graph of 1 there to compare it to. Okay, so I got to see how this one changes to get to that one. Okay, and what I found on number 9 here is that that it's getting close to is at -1, and the one on my calculator, that log x, it was staying here on the y-axis. Did y'all catch that? So it scooted it to the left 1. So to show that this scoots to the left 1, We know, remember, left and right goes opposite ways, so I've got to add 1. But if I just stick if I write my g of x, because it said g of x, if I just stick the plus 1 on the end, that's wrong, because that makes it up and down. To show that it's m with just the x, you got to put it in that parentheses like that. Okay, now there's 2 points on number 9. You get 1 point for having that equation because it says describe and write the rule. So there's the rule. Now I got to get a point for the description. I just got to say it moved 1 unit left. So you had to have both of those to get complete credit for number 9. You got to describe it and write the equation.
Do you mind if you just put an arrow?
That's fine. Yeah, that's fine. That's the way I did it most of the time in class, isn't it? Alright, so number 9, it wasn't too hard to tell on that one. Number 10's not too hard to tell. It's down on a couple in a minute where it gets a little bit harder. On number 10, go back here, I typed in y equals e to the x. I went to my graphing buttons and typed that in, and I got something that looked similar to that. But the one they give me on my paper is like that. So what that is it is reflected over that y-axis. We know where reflection deals with putting a negative. So I might have had to search back into some notes and see if on the y-axis, if it goes in front of the whole thing or just the variable. Did anybody get that? Which one does a y-axis, where's the negative go on a y-axis? In front of the whole thing or just the variable? Just the variable. Very good. So it would be e to the negative x. So there's 1 point. My other point is reflected over the y-axis.
So if it was a reflection over the x, you'd have a negative e to the x?
Yes. Yes.
Would you put the e and x in parentheses?
On the one that Kylie was talking about? You could, but it wouldn't matter. Alright. 11. Let's see here. 11, when I typed y equals 1/2 to the x in my calculator, I got something that's over here, and then but it leveled out there on the x-axis. Then the one that they gave me came on down like that. Now what confused people was they were kind of, and I drew mine right on top of each other. I don't think they were exactly on top of each other, but over here on the negative side over here they were kind of close, and so that confused a little bit, but confused some people. I can't speak today. But we remember that as these things explode up, that it's like they're approaching an asymptote. They get closer and closer to something. So that's not really important. What we noticed here is that from this black one to the blue one, it's scooted down. Okay? So I just saw that this one was on the x-axis, and then I looked on my paper and saw where this one was leveling out, and it's leveling out at -2. So for my g of x, I'm taking that same thing that I had up there, and I'm bringing it down 2. So there would be a point, and there's my other point, right at the way David said.
I did something really good.
What'd you do?
I did a horizontal stretch by 2.
Yeah, and the reason, that's what I was saying, the reason you would think that is because it's close over here, but I don't know how to say it other than it's just, because it's its asymptote, it's what it gets closer and closer to. I get why you think that though, because it looks like this stayed the same and we drug this down, but all exponentials will be getting close to the same thing over there. Alright, then number 12 out of those 4 was the toughest in my opinion, and the reason it was the toughest is because it moved 2 ways. So let's talk about it. It had y equals e to the x, and I had already graphed that one earlier on number 10. I saw that on number 10 that looked something like that, right? But now the one I've got here on number 12, it comes way down from that, and it doesn't cross the y-axis as soon as that. I don't know, I didn't draw that perfect, but something like that. Alright, so I thought the first move was easy to tell here, is that it went down, right? So I looked and saw how far down that was, and that was at a -3. So I know I'm going to go down 3. Okay, then the other thing, and I didn't draw it very good here to see this, but the other thing is that it's moved left. Okay, so what you could, and what I showed somebody on your paper to do would be to go to this curve where it starts curving real sharp and see how many it scoots over on the blue curve where the blue one started curving real sharp. So if you look at your paper on that, it's actually, the curve real sharp is actually down here on the one on your paper, isn't it? But if you move that over from the x-axis, how many did you move over from the x-axis to where that curve real sharp happened? And it'd be at the 2. That's right, Kylie. So we went down 3 and left 2. So there's 1 point. Now to write this all, g of x equals e to move left 2 goes with left and right goes with the x. So I'm up here in the power. Left is plus up there in the power, and then down 3 would be stuck on the end. So you need all of that. The curves on those graphs are sometimes the best places to go to see what changed because they're more obvious. The other stuff is it levels out up in the y, like going up here. Sometimes it's hard to tell because they just get straighter and straighter kind of looking.
So if you plug that into the calculator, it should look like what it gives you?
This here, yes. Yes.
Oh, I remember.
Does it look similar now? Good, 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 good. Alright, I told you I didn't follow the directions on number 13. It said without calculating. I'll show you real fast how you do it without calculating. And so it's probably even faster, but I just wanted to be a rebel. I guess I'm plugging in my calculator. This log base 6 of 13, we didn't talk about a change of base rule. There is a rule called the change of base rule. And the reason we didn't talk about it is because your calculators can do a base, any base. I used to teach the change of base rule pretty hardcore. That was before I knew the calculators could change the base. I thought, remember when I told y'all I thought the calculator only had that log button over on the left side? So I had to use this change of base formula a lot. But then I figured if somebody taught me I could hit math and I can plug in any base I want. So I didn't need the change of base formula anymore. But all that change of base formula does is it tells you when you've got a base other than 10, that you can rewrite that as a division problem with the big number divided by the log of the little number. And I don't know enough about, I haven't studied logarithms enough to know why that works, but it does. You can check it out on your calculator. It works every single time. So these are the same. And so log base, if I change those both to log base E and log base E, that would make it be the ln, which would still be the same. Now I got in my calculator and rounded it to the nearest hundredth, and I got them all of 1.43, which is I bet what y'all did, right? So yes, they were all the same. That one didn't ask you to explain why. I was surprised they could have got a lot of points out of that question, but they didn't ask for it.
Hopefully the one on the test.
Usually they're the same format, aren't they? Alright, back page. Whoop, whoop. I like the back page because we finally get to solve some stuff. I'm a solver. Where'd my mouse go? What'd you do with my mouse? It's not moving. There you are. Ah, going crazy now. Okay, we got 2 to the 2x minus 1 equals 8. I probably got asked about this problem more than any of the other ones, and I got irritated because that's one of the easiest kind that we did. It's when we started solving, this was the first kind that we solved. Then once I reminded them, I was like, 8's the same as 2 cubed. Every time they're like, oh, I forgot. It drove me nuts. But since when we've got a variable in the exponent, we need to write these with the same base. So this one's already got the 2. 8 is the same as 2 cubed. 2 times 2 times 2 makes 8. So now we got base and base the same. We just set our powers equal to each other. Add your 1. 2x is 4. Divide by 2. And x is 2. Good deal? Alright, we ready for 15? Trying to let some people take some notes on that. Got a couple still writing. Okay, tell me if you need me to go back. I can. On 15, I've got log base 2 of 7x plus 9 equals 1. The thing I told you on this kind, when you only have log on one side, write it in exponential form. So there's my b, there's my n, and there's my e. So I've got 2 to the first is equal to 7x plus 9. 2 to the first is just 2. Subtract middle school equation, subtract 9. 2 minus 9 is negative 7. Divide by 7. And you got negative 1. We all right? Number 16, we did one with 10 and 1 over 100 in our notes. That was just like number 16. We had 9 to the x equals 1/3 over 2x minus 4. So we need to rewrite these with the we need to rewrite these with the same base. So what base number can you use with a 9 and a 1/3? 3, very good. So that to get a 9, it has to be 3 squared. 3 squared makes 9, but there was already an x up there. Okay, to get a 3 here, it's already a 3. We just need to flip it. So what kind of power lets us flip stuff?
Negative.
A negative, and there's already a 2x minus 4. So now I got 3 and 3 the same, so I'm going to set my powers equal to each other. So I'm going to have 2x equals, now at negative 1, I need to go ahead and distribute, so that'll make that a negative 2x and a positive 4. Okay, a lot of people looked at this and said your x's are going to cancel out. No, 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 no. To move this negative 2x over, I would add 2x. So that gets me 4x equals 4. Divide by 4. X is 1. We good? We good? We good? All right, on 17, we got the natural log of 2x plus 5 is equal to the natural log of 3x minus 3. So what we had here, we got a log on both sides, and it's the same. Natural log is equal to natural log, yeah. So that means 2x plus 5 has to equal 3x minus 3. So I just set those equal to each other. Okay, now you got 4 pieces here. So you actually get to decide which of those 4 you want to start with, and there's no wrong answer. So somebody tell me how you went. Subtracted 2x. So that would leave me with 5 equals 3x minus 2x is 1x. Then after she did that, all you got left, that's x minus 3. So you add your 3. And you got x is 8. Whoop, whoop. All right, we ready for 18? Yep, yep. 18, I got y equals 2300 times the natural log of 8t plus 3. Alright, so it says the number of new chainsaws sold t years after the introduction of a new model is given by that function. How many chainsaws will be sold 5 years after the new model is introduced? Round to the nearest whole number. 5 years, and it told you that t is the time in years. So I'm just plugging a 5 in here. So y is going to equal 2300 times the natural log. Oh, I put that parentheses in the wrong spot there, dumb butt. Times the natural log of 8 times 5 plus 3. Now, if you're careful, you can throw that whole thing in your calculator at one time. I don't trust my button pushing skills as much as y'all, so at least I knew that that parentheses made 43. 8 times 5 is 40 plus 3 is 43. So I had 2300 times the natural log of 43. What I did, and you can do it different if you trust your button pushing skills. I still was pushing buttons, but I did the natural log of 43 and got an answer. Then I multiplied it by 2300 and got an answer, just so I was a little bit more careful. It said to round to the nearest whole number. So after 5 years, they had, is a sold or made? They had sold 8,651 chainsaws. Is that what y'all got? Good deal. Good deal, Lucille. Alright, 19 is a 3-pointer. It's got an A and a B and a C. I thought it was pretty easy, but a lot of people, I guess they didn't understand the question. I don't know. Maybe part A was too easy. Maybe that scared you a little bit, because all you had to do was replace the K, wasn't it? Yeah, the K. Everybody done with this one?
Yes.
Alright, thank you, Leah. 19, it says that A is equal to 1600 times E to the KT. So there's the equation. It says an endangered species of bird has a population that is modeled by that, where A in hundreds represents the current population of birds T years from now. Okay, so then part A says scientists recently discovered the K value or rate. So this K value or rate, they figured that out, that it is negative 0.23. Okay, then it says write a function that tells that. So I just have to take this and plug the negative 0.23 in for the K. So my part A answer says A is equal to 1600 times E to the negative 0.23t. So that's all you had to do on A. You just replace the K with what they told you it was. Okay, then part B, it says tell whether that represents a growth or a decay. We did one like this, I think it was on a worksheet that we did earlier, where what happened if you had a negative power? What kind did that make it, a growth or a decay? A decay. So even though our B in this case is E, right? And that's funny to say. Our B is the number E, which is 2.7 approximately, which is bigger than 1. This is a time when that doesn't matter. The negative exponent trumps it, makes it a decay. I wonder if people will still say trumps it now. If your power is negative, yes ma'am.
But if the power weren't negative,
It would have been a growth, right. Alright, then part C says, tell what will the population be 6 years from now. 6 years from now is your time. So you're plugging a 6 in for that T. So you would have A equals 1600 times E to the negative 0.23 times 6. And does it tell us, it doesn't say what to round to, but you're talking about a species of bird. So you want a whole bird. Don't bring me a little wing or anything. To the whole bird, that would be 403 birds. Is that what y'all got?
So you would round up?
Yeah. When you're talking about actual things, animals, humans,
I put
chainsaws.
402 because I didn't know if it was.
me too.
Yeah, we debate that every year. Do you give it the whole thing, or do you? My analogy is this: if this bird had had an accident and lost a leg, it's still a bird. So I would still round it up to the whole bird. That's how I play
What about
that.
baby birds?
It's still a bird.
Yeah, but they're not
It's a
like
whole
an
bird.
adult bird.
But it's still a bird.
I'm like,
That's like a baby. A human baby is still a human.
That's true, but when you go to restaurants, they say like 5.5. I don't know if
I've
you know
never
that.
heard them say that. I'd be mad.
No, they don't count it as like a real seat because they use the baby carrier, but they have to count it as like part of the seat because it takes up part of the aisle.
That's crazy. Huh. Alright, we good to go to 20? 20, thank you, Caitlin, has got 2 points. Says, and this is what the last thing that we did, what day would that have been, on Thursday, the last thing that we looked at. It says the table shows the number of rabbits are in a particular forest T years after a forest fire. Write an exponential model to find how many rabbits it will have to make the population 20,000. So first thing you got to do is write the model, and then you got to solve it for when your population is 20,000. So you can pick your 2 points out of that. Remember, that was step 1, was to pick, well, actually we have lots of steps, but first thing I do is narrow it down to 2 points. I used 160 and 4 1620. What we discovered was somebody in one of the afternoon classes was that 0 would not be a good one to use. Because what is anything, that first one that had 0, 20, what's anything to the 0 power? 1. And so that created a little bit of a dilemma because it took the whole b out altogether, because b to the 0 is 1. So I would say don't use the 0 one. Did anybody, I saw Caitlin use those on her paper. Did anybody use different ones? Mason, did you use those same ones? Okay, so even if you use different ones, we still should get in the ballpark. But here we go with these. Remember, the exponential is y equals ab to the x. This is my x and y, so I'm going to start off with 60 equals ab to the 1, and 1,620 equals ab to the 4. That was first thing, was we wrote our 2 equations. Now I'm going to solve this first one up here for a, so it's, bless you, it's being multiplied by b, so I'm just going to divide by b. So a would be 60 divided by b. Okay, then we took that, we plugged it in our other one in the a spot, so we had 1,620 equals 60 divided by b times b to the 4th. Remember that b to the 4th, that's actually on top. It's an understood over 1, so you can reduce your b's now. b to the 4th over b is the same as b cubed, right? Feel okay? Alright, now what would we need to do? Good job. Good job. So that got me 27 equals b cubed. And right, Malia, you want to do the cube by cube rooting? Cube root of 27 is 3. So I got a nice pretty whole number there. Now I'm going to take that, let me get a new color here so you can follow me. I'm going to take that and I'm going to plug it back in here to figure my a out. So a is 60 divided by 3, which means my a is 20. So to finish out my first point for number 20, I got y equals, or if you wanted to use f of x since it's a function, that's okay, 20 times 3 to the x. So there's my first point. If you put your x inside the parentheses with the 3, that's okay. Remember, Thursday I showed you there's different ways of writing that. So there's my first point. Now my second point, it says use that to find out how many years it will take for the rabbit population to surpass 20,000. So I'm solving for years. That's my exponent there. And technically, if somebody mean graded me right now, I might miss this. Because it told me in the problem to use T and R. So, I mean, obviously I'm not going to grade you wrong because I did it. But that would mean that R is equal to, the rabbits is equal to 20 times 3 to the time, right? Okay, so I'm wanting the rabbits to be 20,000. So 20,000 goes in here. Times 3 to the t. So my first thing to do in solving this is I've got extra junk of that times 20. So I'm going to divide by 20. I had some people grabbing their calculator here and I about smacked them. First thing, you can mark a 0 out. Common sense there, right? So now I got 2,000 divided by 2, which is 1,000. Would equal to 3 to the t. All right. This is exponential form. I'm trying to solve for an exponent. What do we do when we're trying to solve for an exponent? Put it in log form. Very good. So I would say the log base 3 of 1,000 is equal to t. And that confused some people because the sides were flip-flopped. That doesn't spell bin right now. This would be n equals b to the e. It's kind of backwards, but if you can flip-flop that if it bugs you. All right, now this is 3 to something equals 1,000. This is not going to be a whole number. So let's think about some common sense before I write my answer, before I let you tell me what you put. Would this be a time when I would round it to the nearest whole number, or would a decimal be better? What am I finding here? Years. And do we ever talk about partial years?
What kind you have months?
Yeah, I mean, we break down the days. That's a partial year, isn't it? So this would be a time when it would be when you round to a decimal. It didn't tell me where to round. I did hundredths. I said it'll take about 6.29 years. What'd y'all get? Good, good. All right, so that would wrap that up. Any of that I went too fast on, you need me to go back to or help you with or show you how to push something on your calculator, any of that? I heard all throughout the day on Friday that people felt better about this one than they have any of them so far.
Yeah. The only ones with the graph.
Right.
As soon as I it's right there on top. I'm looking for it. It's sitting right there on top. We can just hold it. All right, you'll be able to use your notes and your study guide, so have them with you tomorrow.